Alright, so I'm going to go through the review for the final. I know we've already gone over some of it in class, so feel free to fast forward and move back and forth as you need to. Reminder, you do not get to use the actual review on the final, but knowing how to do the questions is going to be crucial. So remember, you can make a single sheet, either notebook paper or computer paper, and you can have whatever you want to on that. Okay. Alright, so number 1 says, what is the range? So remember that range is y, domain is x, values, range is all your y values. So basically here we're looking at these values. So we have a 4, we have a -1, we have a 6. We don't need to list this 4 a second time because it's already been listed once. And then we're going to put these in order from smallest to largest. So we got -1, 4, and 6 that we put into our little set notation. So that is answer B. Okay. All right, transforming the graph. Okay, so there are 4 things actually here that are going to affect our graph. First one is this negative symbol. The second one is this number in front of the parentheses. The third one is this +3 right here. And then the last one is this +4 out at the end. Okay, so if I look at those 4 things, okay, the negative is going to change the graph. So instead of my graph going up like this, it's going to reflect and be upside down. Okay, so this is a positive, this is a negative. So that's going to reflect across the x-axis, or you could say flip or upside down, or whichever, any of those that make you happy for that. Okay. All right, the 2 here in front is going to, instead of our parabola or our graph or whatever being this wide, it's going to narrow it, okay, by a factor of 2. So the 2 in front is going to make our graph narrower, and we actually call that a horizontal compression. We're gonna take the edges of that graph and we're gonna push it together. We're gonna compress, push it, make it skinnier horizontally from left to right. So a horizontal compression. Okay. The +3 inside the parentheses is going to move it left or right. Okay, it's actually the opposite of what we would normally think. Normally a plus we would think moves to the right because that's the way our x values get bigger, but it's actually backwards. So this is going to translate or shift our graph 3 units to the left. A +3 goes to the left, a -3 would go to the right, and that's when it's inside the parentheses there. It's going to go left or right, and the number outside by itself is going to shift it up or down. So a +4 outside or at the end of our parentheses is going to translate our graph 4 units up. Okay, so again, inside this parenthesis, a plus is to the left, a minus is to the right. Out at the end, a plus moves the graph up, or a minus moves it down. Okay, that's one of the free response questions, is knowing what those numbers do and being able to describe that in words. Okay. All right, which interval is shown on the number line? So over here we have a closed off point here, closed at -1. Here we have an open circle, which is going to be our parenthesis. So looking at the 2 last ones with the brackets and the parentheses, this matches what we have here. This one doesn't. So D is good. 3 is bad. Make sure the numbers are right. -1, 3, yeah. Okay, so as far as our inequality goes, if it is a closed circle, it's going to be a greater than or and equal to or less and equal. Okay, if it's open, it's going to be just greater than or less than. Okay, so this is the equal sign here on this end, and this is not equal. So we want an equal sign at -1, which they both have. Equal sign underneath here at -1. We do not want an equal sign, so this is bad. That's what makes that wrong. This is good. So yes, no. Okay. All right, for end behavior. So we're going to take this equation right here. We're going to type it into our graph, and we're going to look at a picture of it. So 5x squared plus x minus 16 looks like this. Okay, so I'm actually going to zoom out just a little bit. I'm going to go to menu, zoom, which is 4, zoom out just a little bit. Okay, so this is a parabola, and it's going to look like this. It's really skinny, and it goes like that forever and ever, right? Okay, this is my axis. Oh well, that's not true. It's like this, whatever. Okay, so as my x values get bigger, so as I go this way along my x values, what is happening to this graph? Okay, as I take this graph and I continue it and I move my x values further to the right, this arrow tells us that our graph is going to keep going up and up and up, right? So as my x values get bigger going this way, my graph gets bigger and it heads towards positive infinity, way up there in the sky, right? So the way we write that, as x goes towards positive infinity, y also goes towards positive infinity, that way. Okay, but going the other direction, because we have to look at both ends of our graph and behavior, both ends, as we go this way, as x's get smaller, what's happening to our graph? This arrow right here says my graph is going to keep going up, 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 up as we move farther and farther to the left, or our numbers get smaller. So it's still going up, which are positive infinity values. Okay, so both of my end behaviors here are heading towards positive infinity, which are these right here. As x goes to positive, it goes to positive. X goes towards negative infinity, it still goes towards positive. Okay. All right, 5A, identify the intervals where the graph is increasing. Okay, so this arrow right here just means that my graph is going to keep going down here. Okay, but this line itself is going up, right? Do you see how this line is increasing all the way along here? It's moving upward. So this line is increasing, and then it turns right here. So this little section right here is decreasing, going down, and then this section right here is increasing again. Okay, so my entire graph up to this point, everything on this side here is always increasing. This always has a positive slope. My line is going up. This little section right here, the line is going down. And then this section here with its arrow going to keep going forever and ever is always going to be increasing as well. So the intervals where our graph is increasing, if x is smaller, less than, smaller than -4. Here's -4 right here. So if I only look at this section of my graph where x is less than -4, is this line increasing in that section? Absolutely. So this is a yes. Okay. The next section is from -4 to +1. So if I cover up these sections right here and I just look at this little section right here, is my graph increasing? Is this line increasing? Yes, it is. It's going up. So that's positive there. Yes. Okay. The next section is from 1 to 3. So x is between 1 and 3. So in this little section of the graph, is it increasing? No, that's decreasing. And the last one is anything greater than 3. So all of this forever and ever is always going to be increasing. Okay, we're going to skip part B because that's a dumb question. I don't know why I put that on there. I'm sorry. Okay. All right, and then number 6 says given f of x is x squared, so I'm going to graph x squared as my original function. And then my new function, g of x, so I'm going to hit tab and get another graph, parenthesis x plus 2 squared minus 5. Okay, so in my picture, this is the red and this one is black, and I'm comparing those. Okay, so it says, is this true or false? G of x is the black one, so the black line is the red line translated down 2 units and 5 units to the left. Okay, so we're going to check the vertex, or the point, right, the minimum or the maximum, minimum in this case at the bottom. Okay, so right here where my arrow is, that's the vertex of the original. It's at 0, 0, and my new one goes over here and then down to right here. So did that move 2 units down and 5 to the left? 2 down, 5 to the left would be over here. This went 2 to the left and 5 down. So this is false because it went 2 left, 5 down. Okay. All right, is g of x wider? Okay, is this graph wider than the first one? Okay, so what I'm going to do is I'm going to grab a piece of patty paper real quick. I'm going to show you. Can we see through this? Can you still see the graph? Okay, I'm going to trace the red one, which is a little bit hard to see because it's pretty light. Okay, that's the red graph, and I'm going to slide it over to the black one. Did it get wider? Can you see that? You see how it's exactly the same? It's just shifted down. It actually looks like it's bigger because we see more of the graph, okay, but that's just our eyeball kind of tricking us. These graphs are the same width. There is no number in front of this x squared. If there was a number right here in front of x squared, that would change the width of our graph. Okay, g of x is 2 to the left, 5 down. That's what we already said. That's true. G of x is the same shape. True. These are both parabolas, which is that U-shaped graph with its vertex. Okay. All right. Other things from this first unit that are going to be on the test. You need to know this. Know all your graphs, the domain and range, and behavior for each parent function. Be prepared for that. We've spent that a long time on that part. Okay, so I'm going to stop here and I'm going to start a new recording for Unit 2. Okay? Okay, remember, do all the problems and then go back and write your cheat sheet. Okay? After you have all the problems done, decide what you need to put onto that cheat sheet. Okay? Make sure you bring that to class with you tomorrow. Okay, love you, bye.